Right. Now, these two things we've not done in here, half reactions and Boyle's Law. You probably did Boyle's Law in physical science. The way, remember, this is not meant to be a super hard course, okay? And so when we are dealing with half reactions, that means that we're dealing with an oxidation reduction reaction. Okay, better known as a redox reaction. Now, we have not done these in this class simply because there has just not been enough time. But I think that I can show you one thing that will really help you for this test. Now, a redox reaction involves transfer of electrons. Okay, we're just moving electrons around. So take, for example, if we were to use calcium, pure elemental calcium, something that is in its elemental state has zero charge. All right, now if we were to change that into an ion, then that means that the calcium would have a +2 charge, and that it has lost 2 electrons. Now, the way that we write this, first of all, the term half reaction, I'm not going to explain it, because if I do, it will get very complicated to you. I'm going to make this as simple as you need to get you through this test. That is your goal, to get through this test. So the way that we write this in a half reaction is going to be simply calcium with a 0 charge turns into a calcium with a +2 charge plus 2 electrons floating around. So what this means is 2 electrons are transferred to whatever they're transferred to. Now, let's take a look at something like bromine in its elemental state. It likes to become a negatively charged ion, an anion. So if we add 1 electron to that, we would get bromine with a negative charge. Now for this one, we have very simply transferred 1 electron. Okay? So if you see something on here that says, in this half reaction, how many electrons are transferred, you find the number of electrons, that's how many electrons are transferred. In this case, 2 were transferred. In this case, 1 was transferred. So, this is a very, very complex thing whenever you put it with all the other stuff that goes with it. But we are not doing super hard reactions on this test. On this test, you will probably just be asked to know how many electrons are transferred. And one more time, the way that you know how many electrons are transferred, you just look in front of your electron sign. In this case, you've transferred 2. In this case, you've transferred 1. Okay? And you might see something like aluminum with a 0 charge. going to aluminum with a +3 charge, and then you got 3 electrons that were transferred. Okay, so 3 electrons transferred to something else. That's all that means. Now the next thing I want to cover that we have not covered in this class, but you've probably covered it with your gas laws in your physical science class, and it's called Boyles Law. It does not matter what the name is. The formula is given to you, but it means the pressure and volume in your first scenario are going to equal the pressure and volume in your second scenario. Okay, so let's say you have a problem. A tank of some kind of gas holds 3,200 liters of some kind of gas. At a pressure of 1.25 ATMs. ATMs is just a measure of pressure. It stands for atmospheres. Okay, so this is your volume and this is your pressure. What is the volume if the pressure was reduced to 0.9 atmospheres? Okay, so you're using this P1 V1 equals P2 V2. Just like before on the concentration dilution problems, the only thing that you can do wrong here is getting your P1 mixed up with your V2 or whatever. So again, I'm just going to use my little box thing. Okay, I've got a tank of gas that holds 3,200 liters at 1.2 atmosphere. Okay, so this is one scenario, so I'm going to call this my 1. And then it says, what is the volume? So this is what I want to know. I want to find out volume at this pressure. Okay, so I'm going to call this my 2. Alright, so P1 is going to equal, so my pressure 1, here's pressure 1, 1.25 atmospheres. And my V1 is 3,200 liters. That's a pretty big tank. My P2 is 0.9 atmospheres. And I want to know my V2. Okay, so the formula, you're not memorizing the formulas. The formulas are given to you. P1 V1 equals P2 V2. So if you're solving for V2, it's going to be P1 V1 divided by P2. Okay, so my P1 is 1.25 atmospheres. My volume 1 is 3,200 liters, and I'm going to divide that by my P2, which is 0.9 atmospheres. So I take 1.25 times 3,200, divide that by 0.9, and in this case I get a pretty big volume. That tank is going to have to hold 4,444 liters. Okay, I rounded. It's actually going to have to hold 4,445 liters if we were to have a tank. Okay, so now we haven't done these problems in this class, again, because I didn't have time to get this far, but all you're doing is substituting numbers. So in order to keep from, the only way you can screw this up is by not getting your ones and your twos straight. Okay, so just decide that, okay, this is going to be my scenario 1 and write a 1 by it. This is going to be my scenario 2, write a 2 by it. Write out your numbers, substitute them in, and solve the problem.